So come to this video whereby we are going to design this building. This is a residential building, G+1. So we're going to do the structures. So let me first show you something here. So this is the building we're going to work on. Here we have a ground floor. Then here we have the upper floor. So here's a quick look at the ground floor. Yeah, so this is the ground floor. We have a living room, then a terrace, a dining, foyer. We have a kitchen. We have another foyer here. We have an exit shed. We have a terrace, and big toilet and bathroom. Then moving on to the first floor. On the first floor, we have a master suite just in front with a walk-in closet, master bathroom, prayer room, balcony, bedroom, T&Bs, then plus some roof below. So take a note of this roof. This roof is between G and I. So now what I'm going to do, I'm going to save this file as DWGs. So I'll start with the first floor. Come to file, save as, file, export, DWG. So I just say next. Then I'll give it a location folder, then I save it as this. Then I'll say okay. So it will be saved. So I'll do the same for the ground floor. So when I'm done, I'll just close this file, then open my structural template, my new structure template. How do I open a new structure template? I come to file, new project, browse, then I go to under desktop, then I look for structure template. I say okay, then open it. So when it loads, I'll come to my elevations, then I'll set these levels to match the architectural levels. For example, if I go back to the architectural level and open this section, so actually I'm pressing WT to tile. So you realize that in the architecturals we have a first floor at 3.5. So I'll also set this side the first floor. Then the wall plate at 7K. So after setting that, I'll press TWD to TW, maximize the view. Then open the ground floor. Now what I'm going to do, I'll close this architecture. So I'll also open the first floor. So I will tile. This side I have the ground floor, this side I have the first floor. Then I will start positioning columns accordingly. Yeah, so you realize I placed a column here. Then I have these 4 circular columns, big ones, and corner. So how do I put a corner? Press CL. Alternatively, come to structure column. Then I'll come under properties. Look for concrete round. I'll come and this one here. So I'll get move tool, pick its center, copy there. Then get copy, pick the center, continue around here and here. So I'll get a line, align this, get this center, I need to use this, get this big line, get this center, align it with this. So I'll select these two columns as a. Before selecting, you realize that this column is kindly slightly off. Yes. So since this is perfect aligned, I will get its center, align it with this. Now you remember in architecture we had this roof which was this point G. Now having set everything well, now it's time to put beams. So to put beams, I'll maximize this window by pressing TW. Then for proper visibility, now to get a beam, I can press BM or I can go to structure beam. Then I'll come under properties. I choose this beam 400 by 800. Remember, we're just choosing random sizes because after this, we need to go to Etabs and analyze and redesign. So I'll come to this column here, up to this column. Then I'll go straight up to here. Then come and close it here. Press escape once. Get this center. Also drive this beam up to here. Escape once. Get this up to here. Then continue up to this column. Take it up to here. Come here. Bring this up to here. I'll save later. Like this. To this point. Then get this. Get this. Get this. Bring it here. Now this beam at this point will be cantilevered. So no worries, we shall design for that cantilever. Even this beam here will also be cantilevered at that point. This one here Yeah, so come to Revit here. Then I'll come to modify beam, get this extend, click on this green, extend this beam here. Still press BM, get this center up here. So I have less the beam actually. Now realize that this beam is supposed to run throughout this beam along F. So I'll get this extend, click in the center of this beam, then click on this beam along F. Yeah, you take a note that we have a void. So what I'm trying to do is what they call structural layout. This beam will also come up to this point. Now we have to deal with this balcony. Now this balcony has a slab that comes from this beam, comes up here, then goes back. But then on the roof, it's a circular ring beam. So pick this data. I'm also going to put a beam, but we shall have to delete those beams. So I'll press BM. So I'll get pick lines. Pick this inner line, inner line, inner line. Then I'll also pick this circular one here like this. Then I'll get this. In fact, I'll get trim. Then trim. So I've got the ground floor. Select these 4 columns. So I'll say copy to clipboard. Come to paste. Selected views. I put them on the first floor. No. Control Z. Now these columns were supposed to run from the foundation up to the very last point. So they are continuous. So it goes up to all plate. So when I open my first floor, I'm supposed to see these columns. So far so good. Come 3D, then I see what we have. Right click and say zoom to fit in case you don't see anything. Come to section box and uncheck it. So don't mind about this this building on top. Just delete it. So far this is what we have. I can hide these DWGs. Now what I'm going to do, I'll click on one beam, press SA, select all of them, copy to clipboard, paste selected levels, all plate. Then I'll come to all plate level, select, right click and say select all instances visible in view. I'll change this to main view. And I'll say what 3D. Then So this building is going to be built in an area which has loose soils and is susceptible to earthquakes. So meaning I might need some ground beams. Now the easiest way of getting ground beams, because actually if you look at the 3D, right now we don't have ground beams at this point here. So to get ground beams, just go to the first floor slab, select our tile, click on one, right click and say select all instances, visual in view, copy to clipboard, select selected levels, ground floor. Then I'll say okay. So when I go to ground floor, right click and say select all instances visible in view. And I'll change this to, I'll just change it to anything. Let's say this, edit, rename, call it round beams. And I'll say maybe size, let's say 200 by 300 millimeters. There we go. But then I don't on the ground need this. I think I need it. I need it. So this is what we have, our skeleton. So to make this ground floor neat, I'm going to select the DWG and hide it in view, such that I'm left with something like this. Now I'm going to put foundations. Now to put foundations, excuse me, go to structure, isolated. Then come here and choose footing F1. You say add columns. So highlight everything and they will automatically be created. Then come back and inspect some points such as this. So here we might need a combined footing. So we shall correct that during design. So this is pretty much of it of the skeleton. Fancy colors and put texture. Here you see all the concrete. So now we have to export this to Etabs. Now for us to export, let's first save it. Ctrl S. Get a location. So I call it structure. Residential. Save it then. Now, remember, we have to export this to Etabs for analysis. Now, for us to export it, you don't export everything. You just export the analytical model. What is an analytical model? An analytical model is like a framework or a statement of a frame whereby only takes the centers of center lines of the structural elements. Now this takes the freeboard diagram of the structural elements. Now, for us to be able to accurately take the center lines, so we just need to come to like these beams. For example, I'm going to open an elevation, like elevation 2A. So now you see like this beam. And like these beams, they appear to be sitting on top of the floor level. Here, in actual sense, is supposed to be this part. The upper part supposed to be at this point. Now, for example, if I click on one beam and I press SA, I come under properties here. You see this Z justification is saying bottom. If I put it top, I'm going to see something. You see, it adjusts automatically the way it is supposed to be. Now, however, for us to make an accurate analytical model, we need this center line, these beams to the center lines of the beams flash or to match with the flow level such that all the center lines are intersecting well. Now, for us to achieve that, I could either still leave it at the Z justification, I can leave it at bottom, but then I first come to edit type. I check the depth of the depth of those beams. So it is 450. So now I will offset it downwards by a half. So if I get my calculator here, let's say 450 divided by 2, that is 2 to 5. So meaning I'll come to start and end offset and I put minus 2 to 5. If my Z justification was top, I will instead have offsetted it by a positive 2 to 5. So click apply, and it will automatically adjust. So I'll do the same, select all instances, visible in view, edit type, check and confirm the depth, it is 300. So meaning I'm taking it down by minus 150. Why I'm doing this is just to get an accurate analytical model. But during detailing, I'll need to take it back. In fact, I'll take it such that the Z justification is reading bottom. No, sorry, top. So there we go. Now about 3D. Everything looks fine. It's fine except I don't need this. Level flavor equals of background level. What else? If I click on this circular beam, realize that it didn't go by that offset. So I'll try to put it simplify life. I'll just select all of them, put it again minus 150, minus 150. Then I'll save my model. Then now I close all other windows. So I need now to generate my analytical model. So how do I generate it? I'll first activate this show analytical model. When it is showing yellow, it means I'm in position to see my analytical model. So I'll take this to hidden. But right now I can't see any analytical model. So what do? I come to analyze, you say analytical automation. So right now, what we have is a physical model. Now we want to take it into an analytical model. So meaning, yeah, we have the options. It is analytical to physical for buildings or physical to analytical. So you guessed it right. We are going to take a physical to analytical. So just click on it. Just give it some few seconds to load. Then here we just have a few steps. So suppose click on select, then zoom out a little bit and select everything. So here it should show you that it has selected 126 elements with a green tick. Update parameters. Just leave the rest to default the way they are. Click on run. So right now it is generating the analytical model. So once it says run complete, it means it's done. Then you can click. You can just close. So I think when I select this, you can see something in the middle. So now for us to see the analytical model very well, put this to find the time, then put it to wireframe. So I think now you are seeing some dotted, not dotted, but orange or yellow or brown lines. So those are the analytical or the lines that we wanted. So right now I'm good to export to Etabs. So how do I export? I come to add-ins, external tools, export to create Etabs, save or sub 2000. So by default, it will tell us that we have 120 analytical members and grids. Otherwise, if we had not generated an analytical model, this option would be off. It would only export grids, which would make openings quite difficult. So here it is. In case you have Etabs version lower than 2017, you can check this. Or sub 2021 or save 2016 or earlier. So you say, okay. Press OK. Then Revit allocation. So yeah, I'll create a new folder and I'll call it analysis. I'll click on it, then save. Then I'll open my Etabs. So my Etabs is opening. So excuse me. So once Etabs open, so just come to File, Import, Revit Structure, and go to the folder. So the folder is called Swan analysis. So this they open. So let the file open. Just press OK. Save. Done. So on the left, so here we have three panels and tabs. This is called the Model Explorer. This is first window showing us the plan, second window showing us the 3D. So I'll try to minimize the Explorer part. So on the 3D navigation is either just press shift a bit, just press shift and middle mouse button. Pan, just middle mouse button alone. So before doing anything, I prefer checking the model. Just come to analyze, check model, select all. Okay, then let it check and see if we have any modeling issues so far. So it is telling us what has been checked, no one is generated. So I'll come to define materials. I'm adding here Europe. Though in case you're in India, Australia, New Zealand, you can choose accordingly. So I'm going to define the concrete. I'm waiting 0.2 part 1, part 1. So I'll choose a class. I'll start with 2530. So see 2530 means the tube strength is 30, the cylinder strength is 25. So I'll say okay. I'll come to modify material data. Just confirm that cylinder strength is 25. There's some material damping properties. This is 5%, which is 0.05. So okay, adding here. Let's also try 20, 25. Material damping is 5%. Then adding here. This time round we are going to add rebar. Say okay. So for me, FYK 500. Click on show material property design. So grade is 500. Minimum yield strength is 500. Okay. Then come to define section properties. Let's first define the beams and columns. So currently, you see you have this beam 400 by 800. So I'll click on modify. So when I click on modify, go to depth and this. So meaning I'll call this beam 400 by 450. Material, I'll start by giving it 2530, commonly used in my country. Then I'll come to property modifiers. Now when I come to property modifiers, I have a cross section, I have shear. Now, what does this mean? When I say cross section visual area, so when I leave it at 1 that is 100 over 100 giving us 1, so which is 100%. So it means during analysis, the entire area of that section is considered, which is okay. Then when I come to area, now shear area in direction 3. So if I try to bring this one a little bit, this is direction 2 upper side. In this direction, the longer side, and direction 2 is this shorter side. So for accuracy, to include factors of errors on site, poor plumbing of structural elements. So it is advisable you consider only 50% of the area will be used in shear. So that is 0.5. Even this is 0.5. Now, torsional constant. Now, for torsional, also consider only 20%. Here, moment, we also consider 50%. For the mass and weight, we consider 100% of the section. So I'll say, okay. Then I'll come and modify these ground beams. Ground beams, I prefer giving them 2025. Now call it one beams, 200 by 300. Modify as before, 0.5, 0.5, 0.1, 0.5, 0.5. Okay. Oops. I forgot something. Maybe if I go back to modify. So we modified the property modifiers, but we had forgotten to set the reinforcement. So for reinforcement, click on this. Make sure if it is a beam, it should read M design beam only. So rebar material, choose the FY500 we just made. Cover to longitudinal rebar centroid. So let's assume you're going to use H16 bars or bars of 16 millimeter diameter for longitudinal reinforcement. Then you're going to use, assuming you're going to use 8 millimeter bars for confinement stroke shearings. So when I say cover to longitudinal reinforcement, so that is the clear concrete cover to the shear reinforcement plus diameter of the shear reinforcements, then plus half the diameter of the longitudinal reinforcement. So getting a calculator, assuming you have a cover to reinforcement as 25 millimeters plus diameter of the shear links 8 plus half of 16 millimeters, which is 8, gives us 41. Man, put in here 41. Okay, so we'll do the same for this. So ring beams also modify. Then also come to column C1. You see, modify property. So on it, I'll change the name to call 400 by 100. And I'll say material, I'll take C2530. This is 200 by 200 property modifiers. It also takes customers pins 0.5, 0.1, 0.5, 0.5. Reinforcements. Make sure it is now reading PM2, M3 design house columns 500 rebar reinforcement material. Reinforcement configuration rectangular. Confinement bars, ties. Sure. Check stroke design. We are going to design. If at all we are going to check, we'll change this to reinforcement to be checked. But we want it to be designed because we don't know yet. Then here they're asking us layer cover reinforcement is 25 So how you get this 25 is through what they call preliminary sizing. Number of longitudinal bars along phase 3 direction. So this is phase 3 direction. Some output maybe 2. Bar size output 16. Number was output 16. Confinement bars I will use 8. Longitudinal spacing maybe 200. Say okay. Then okay. So I'm to disclose it too. Possible call maybe 300. Remember it was rectangular. Sorry, circular. Yeah, to represent diameter. Material, I'll use 25, 30. Section type, I'll change it to concrete slab. Diameter, I'll change it to 300. Now here, it's all the same. All the same. All the same. Area cover is 25. Number of parts, let me first use 6. Size 18, sorry, 16. 8. Spacing 200. Okay. Now I'm done defining the sections that I imported. But then for checking and optimizing, I prefer adding a few new sections so that I check and see how they will be behaving just in case. Now, for example, I'll get this column 200 by 200. I'll say add copy to duplicate it. So I'll add a column of 30 by 230. I'll not change anything apart from this. Also add a column, add the copy. Call it call 200 by 300 by 300, 200 by 300. So now at this I'll try to change this configuration such that I have 3 along the longer face, then 2 along the shorter face. So I'll come and say along direction 2. This is direction 2. I'll put 3. Along direction 3, I'll put 2. This is direction 3. I'm supposed to put 3. Direction 2. So now we are done. Now we need to define slab sections. How to define slab sections? Found section, define section, slab sections. I'll add a new. So I put 150 mm solid slab So I'll get 2530 shell within 150. So type slab. Okay. I'll say add new property 200 and all like area 25,000 slab type rib depth is 200 slab thickness is 15 stem width total is 450. I'll show you how I got this. Bottom is 150. This is 450. So okay. Modify. Yeah, read spacing is also 450. Right. Now I need to start sketching. So how come right now it is plan review wall plate, so I'll go to the first floor. Now before I start sketching, you remember on the first floor we don't have these beams. So what am I going to do? I'll click on this beam, select this joint, and this. Then I come to edit frames, divide frames, divide at intersection with selected objects and joints. Apply, okay. Get this, get this, get this. Press delete on your delete. Then, so I'm now going to start sketching. So I'll click on the slab here, change it to okay. Now, how do I know that I'm going to put a solid? I'm going to put a hole. So I'll come to my architectures. So you know all that only puts solid slab zone.